Hi guys, I'm Jeffrey. Over the past few months, I've been working closely with the Environmental Integrity Project, or the EIP, nonprofit watchdog organization comprised of former EPA attorneys and agents, as well as environmental litigation officers that focus on the systemic issue of coal ash contamination across the U.S. My capstone proposal, a toll farm coal ash, um, seeks to explore the widespread failure of the power industry to clean up coal ash dumps. Um, Over the past few months, I've been working in collaboration with one of the senior attorney directors from EIP, Mr. Russ, and he has provided me with numerous research data as well as reports to support some of the daring evidences of groundwater contamination pertaining to coal ash dumps and coal ash ponds and across the U.S. In every state where coal is burned to power our utility industry, the federal rule known as the CCR rule, or the coal ash rule, enacted by the EPA in 2015, is violated. Um, the widespread contamination threatens our drinking water supply, the aquatic diversity, and also groundwater that are located in areas in which these coal-fired power plants are situated. And these major utility companies have continued um, to avoid cleanup, um, even though there are numerous non-compliance issues with the EPA regulation. One of the things that I start to narrow into is my focus area, which is in the Midwest and also Indiana, on how groundwater contamination from coal ash has threatened this state specifically. And so one of the things that jumped out was that in the Midwest, utility companies produce the most electricity from coal. Um, One of the things is that most of the coal mines are located in the Midwest, um, and it's also the cheapest option to provide electricity for the majority of the communities and the population living here. And one of the things that I noticed was how many coal-fired power plants are located along the Ohio River um, and on the Ohio River Basin, and some of these produce numerous amount of electricity from burning coal, which means there's a lot of coal ash waste. Um, One of the things that is really important pertaining to coal ash contamination is environmental justice, and the burden of coal ash pollution is carried disproportionately by communities of color and low-income communities. And some of these maps here seek to explore and show how severe the coal ash contamination issue is pertaining to the residential population within the vicinity, as well as exploring some eventual flood um, plain issues that can cause serious pollution and contamination to not only groundwater but also affect the health and safety of major water bodies as well as the community around it. One of the things that was important was to ask the how question. So how does coal ash contaminate our groundwater? And these are a series of diagrams to kind of help me understand and help you understand the the process of how coal ash is produced um, when electricity is produced. So every step of the way, there is some coal waste um, that is, you know, leaked into the ash ponds and also the landfills that eventually leak into groundwater. Another thing that was really important was to establish a framework to ask ourselves um, what are um, to ask ourselves, how can polluters thoroughly clean up coal ash contamination? These are a series of questions that explore coal ash cleanup above groundwater and deciding how um, severe the contamination issue is below. One of the important things that is part of the whole remediation process was establishing groundwater cleanup measures as a toolkit. Here, the toolkit is established from the least aggressive cleanup methods to the most aggressive cleanup methods. These are some toolkits that are divided into physical, biological, and chemical remediation methods that are explored. Some are provided um, in, during our research process with the EIP. Some are derived from other research reports and also case studies and precedents that have helped establish the measures of groundwater remediation techniques over the course of, coal ash pollution. Um, as we narrow down into my site-specific area, I'm looking at the Duke Energy Gallagher Station, and this is the one of the sites that has recently been shut down due to an EPA lawsuit and its many regulation and violations pertaining to polluting and extensive leakages of contaminants in groundwater, and also is one of the top environmental justice offenders in the US, the site. One of the things that is very important is to understand how the remediation methods can be applied to the Gallagher site specifically and kind of determining which is the best method for physical remediation here. And by looking at that, I am, deriving these methods from successful applications from past extensive coal ash contaminated areas in the U.S., the Kingston fossil plant, and I've applied that method of a slurry wall and a pump and tree system to the primary ash pond on the Gallagher plant. Here, there's a scenario planning here to kind of map out the time in years, the time in months, um, as to as for the groundwater cleanup, for containing the groundwater contamination cleanup. Next up, we're looking at the biological remediation methods um, of the Gallagher station, and one of the things that I also looked at was some precedent, which is also the Kingston plant, on some of the biological techniques that are used and have been effective over time. And so I've concluded that bioaugmentation would be the best course of action for the North Ash Pond on site on Gallagher. Specifically, there are several potential bacterial species that can potentially resolve the heavy metals that are in this pond and are continue leaking into groundwater. As we move on through the course of this project and this proposal, I am still in contact with my stakeholder on the chemical methods of the best chemical remediation methods that can be applied to one of the further ash ponds down south on the Gallagher stations, and potentially providing a future outlook and connection of where the site can go in the future. Thank you.